this is the outline for today's session, which is reduction formula. So we will look at how to reduce using 180, 360, and 90 and 270, and also use special angles in reduction. Then we will look at compound angles, right? Double angles and triangles and quadrants. So let's start with the first part, which is reduction formula, right? What is reduction formula? Obviously, in reduction formula, we're going to look at both. So we have two types of reduction. The reduction formula, what we are using is we are reducing trigonometric ratios that has 180 plus theta. And so we are using a reduction using 180 and 360 degrees. I call this a horizontal reduction, no change. Okay, so we are looking at a cast diagram like this. And we have studied cast diagram in grade 11. So I'm just going to go over this again, just a brief review. Remember, this is 180, 360 degrees reduction. So I'm looking at, this is just horizontal, right? Because it follows different rule, horizontal reduction. So we will put 180 here on the horizontal and 360 on the horizontal. So if you go above 360, so that's 360, it can also be 0, right? 0 degrees. So let's just call it 360 minus theta. So what is this? Theta, or it can be 360 degrees plus theta, right? So if you're going in this direction, remember we said this was cast, C-A-S-T. Now, if you are going in the anti-clockwise direction, is theta angle, right? So we are in the first quadrant, or we were here 360 degrees plus theta, we added a theta. So we are still in the first quadrant. Now, if you are going down, there's going to be negative theta, right? Or it could be 360 degrees minus theta. So those are the two angles that you are kind of working with, right? It can be negative theta or 360 degrees minus theta. Or it's negative theta angle or 360 degrees minus theta angle. What if you're going before 180? That will just be 180 minus theta. After 180 is 180 degrees plus theta. That's it. So these are the four angles that you need to consider. 180 minus theta, 180 plus theta, right? And those one, negative theta and 360 minus theta. Now, how do we use this horizontal reduction to simplify questions? So I'm just going to give you brief questions, quick. Right, so in horizontal reduction, when you're reducing on the horizontal line, the trig ratios remain the same, no change in trig ratios. So trig ratios are the same, right? So the only thing that you need to locate, trig ratios are the same, only the signs change. Trig ratios are the same, but trig ratios are the same, but only signs may change. May change or may not change. That is because we have to use a cast diagram. Let's just look at some quick examples. So looking at an example, what is sine of 180 degrees minus theta? To find sine of 180 degrees, remember what we are using, just 180 and 360. Sine of 180 degrees minus theta, that will be in the second quadrant. Okay, so we locate the quadrant. Look at this. First, locate the quadrant. This is the first quadrant, right? Sorry, this is the second quadrant. Locate the quadrant. 180 minus theta is the second quadrant. How we know that? This is quadrant 1, that's quadrant 2, that's quadrant 3, and that's quadrant 4. So This is a second quadrant, and in the second quadrant, sine is positive. So just sine theta, easy. B, what is tan of 360 minus theta? So now tan of 360 minus theta, we can see that this here is in the fourth quadrant, but in the fourth quadrant only cos is positive, right? So tan is negative, so just negative tan theta. You can see the trig ratios are remaining the same. That's why I'm saying when you reduce using 180 and 360, it's either before 180 or after 180, right? So you just need to look at, see, trig ratios are remaining the same, still sine, sine. See, over here is tan, this is still tan. It's just that the sign changed to negative. C, what is cos of uh, theta minus 180? Now we got a problem because, see, this negative angle is appearing first, but we are only allowed to use 180 and 360. So this negative angle, right, negative 180, we're going to make it positive. How do we make it a positive angle? By adding a revolution. Now, what's the idea behind adding a revolution? Just say the idea behind adding a revolution is, just say if you have an angle theta here, right? Just say if this angle is theta. Now, if you continue from this point here, right around, okay, I can come back to the same point by adding a revolution, adding 360. Then I can come back to the same point by adding another revolution, and so on. And I can do the same by using anti-clockwise. So you can either add a revolution or minus a revolution. So I'm adding 360, right? So now I'm going to change this question into cos of 180 plus theta. Right, because I added 360, 360 minus 180 is 180. 180 plus theta is in the third quadrant and cos is negative. So the answer is negative cos theta. Let's look at some example like tan of negative theta. That is easy. What's tan of negative theta? Negative theta is in the fourth quadrant and tan is negative. So just negative tan theta. Right? So these are sometimes called negative angles. Only cos is positive because you understand why. Uh, it's in the fourth quadrant. What is cos of negative theta? This is cos theta because it's in the fourth quadrant, and cos is positive in the fourth quadrant. And last, what is sine of negative theta? Sine of negative theta, this is all in the fourth quadrant, right? This is in the fourth quadrant, and in the fourth quadrant, sine is negative, negative sine theta. So this was the quick revision on reduction formula. Guys, I can use any trig ratio, sine, cos, tan, right? And just locate the quadrant after you get it in terms of 180 and 360 or negative angles. Locate the quadrant and just simplify using cost. Let's look at vertical reduction now. This is a little bit more challenging, right? So when we're doing vertical reduction, in other words, 90 and 270, right? I like to use both because why I'm going to use both is because when we are doing trigonometric equations, we need to use them, right? So vertical reduction is using 90 degrees and 270 degrees in your reduction. So now the rules are different, okay? So what happens? It takes co-ratio. So what's going to happen? Trig ratios will change, co-ratios. Now let's look at an example of a vertical reduction. I'll draw some diagrams. Locate the quadrant and then use co-ratios. That's it. So let's look at 90 and 270. So we have a cost diagram here, CAST. Right, so where's 90 and 270? 90 is on the vertical line, 270 is on the vertical line. So now if you're going forward, remember your when you are drawing triangles and stuff, remember your rotation angle is always like this. Positive is always anti-clockwise. So if you're going forward past 90, that's 90 plus theta. If you go before 90, that's 90 minus theta, right? if you go before 270, there's no 180 and 360 now. I took them out because I'm using a different rule. So before 270 is 270 minus theta, and after 270 is 270 plus theta. Right, so now, how do we solve problems with these? Very simple. Let's start with, obviously you're used to 90s, but I will do them as well. Let's look at the first example. I want to simplify cos of 270 minus theta. Cos of 270 minus theta is in the third quadrant. Cos is negative, right? And we said it takes co-ratios. What's the co-ratio of sine? Remember the full word for cos is cosine. Take the co out, you'll get negative sine. That's it. That's your answer. Are we good? So where's 270 minus theta? It's in the third quadrant. In the third quadrant, only tan is positive. So in other words, cos is negative, right? This negative here is coming from the quadrants, okay? This is from the quadrant. And the sine is coming from the 270. You have to change it because of the 270, right? Change the co-ratio. See like here, this was tan, all right? So tan remained tan because you know why? This is zero. It's the same thing as saying 0 minus theta. We kind of like using 0 there. Look at this example here. 360, because of the 360 remains tan, and the negative is because of the quadrant. So make sure first figure out the sign, all right, in the quadrant, and then think about whether must I change or must I not change the trig ratio, right? So first the quadrant, locate the quadrant. Should you change or should you not change? When do you change? When there's a 90 and 270, when you're reducing vertically. Next one. What is sine of 90 minus theta? That is in the first quadrant, all is positive. So positive cos theta. See, sign changes to cos because of the vertical. C, what is, okay, I'm not going to do tan because if you have to do tan, then you have to do sine over cos, all right? So I'll just do that towards the end. What about this one? Yeah, what is cos of 90 plus theta? So now cos of 90 plus theta, that is in the second quadrant, and cos is negative, and cos changes to sine theta. Okay, so it's simple now. It's so easy to use vertical reduction. We can look at one with the tan D. So we got tan, which is, let's just say tan of 270 plus theta. All right, so now 270 plus theta, that is, tan is negative, right? But now tan will change to, I don't know if you remember them, the co-ratio. Remember this is tangent, the other one will be cotangent, cot theta. But cot theta is the same thing as saying negative cosine theta over sine theta. Cos over sine is cot. But you're not going to do it like this. You will do it using sine and cos. So you'll rechange this question to sine 270 plus theta over cos 270 plus theta. So now you're going to do each one separately and you'll come to the exact same answer, negative cos over sine. So let's see. Sine of 270 plus theta, that's in the fourth quadrant. Sine is negative, negative cos theta. And cos of 270 plus theta is in the fourth quadrant and cos is positive there. So it changes to sine theta. So see, we ended up with the same answer. Any questions, guys? We good? Right, so now these are just some basic problems. Now, how is your problem structured? Your problem is structured in such a way that, okay, so now when you're doing reduction, don't forget your identities, two important identities that you have learned. Because when we are doing reduction, you also need to simplify. So the two important identities that you know is that sine squared theta plus cos squared theta must be equal to 1 and all arrangements of this. And you also know that tan theta is sine theta over cos theta. You need to know that. And obviously all the possible arrangements of this. What I mean by that is like, what is 1 minus cosine squared? It is sine squared. So you need to know these as well. Now, next part is special angles, right? What is special angles? Right, so when you are working with special angles, you're going to work with 0, 30, 45, 60 and 90. Guys, only for this you need to use 60 and 90. I would suggest just use a calculator, but for 30, 45 and 60, for 0 and 90, just use a calculator. For 30, 45 and 60, what I suggest is make sure that you know like your triangle stuff, the 45, 45 triangle. If you draw the triangle, it'll be much more easier, right? But it's better to draw this triangle for 45 degree, okay? So draw adjacent of so root 2 and 2. So when you say sine of 45, you're going to get opposite over hypotenuse, root 2 over 2. So you have already simplified that, okay? Next, 30, 60, 90 triangle. Where's the triangle for 30, 60, 90? We have this one here. And remember what you need to use. You need to use SOHCAHTOA, right? And we know that sine of 30 is half. So that's easy. That's half sine of 30. And adjacent is root 3. So the top has to be 60. Okay? Right, so that's great. Now, if you're trying to find what is tan of 30 degrees, it's going to be 1 over root 3. Now, you got to rationalize here. You're going to say root 3 over root 3. So that's how you get root 3 over 3. I think if you type sine 45 and cos 45 on the calculator, you'll get 1 over root 2, right? So 1 over root 2, you have to multiply by root 2 over root 2, which is, what is this? So root 2 over root 2, which is root 2 over 2. So if you can rationalize and show the rationalization in your answer sheet, then you don't need to draw these triangles, okay? But if you draw them, it's much better. But I think for the triangle, what we are doing here, not using root 2, using 1 over root 2, okay? That's root 2. This is your general triangle, 1, 1 and root 2. It wasn't like the other way around. So 1, 1 and root 2. Okay, and for 0 and 90, we're just going to use a calculator. So you know what's happening there. Right, so let us solve some questions before I go on to compound angles and stuff. So I do have some questions for you to solve. And we're going to do them like really quickly. I have 6 questions, so it will build your understanding to the next one, to the next one, and so on. All right, so we got sine of 180 minus x, right? So if we're looking at the cast diagram, right, so we are dealing with 180 minus x, that's in the second quadrant, sine is positive, so it's just sine x dot. Cos of 90 plus x, 90 plus x, that's a vertical reduction, cos, there's 90 here, right? 180, 270, 360. We said 90 plus x. So that's negative because cos is negative in the second quadrant and it changes to a negative sine x dot. Next one. What is tan of 360 minus x? So we are dealing with 360 angle here. So no change in the trig ratio. But the only thing that can change is the sine. So tan of 360 minus x, 360 minus x will be in this 360 minus x go down. So in the fourth quadrant, so it'll be negative tan x, right? Divided by, what is sine of negative x? Great. When you have negative, it means the fourth quadrant. I told you this is 0. It's saying 0 minus x. So we are 0 here. 0 minus x is negative x. We are in the fourth quadrant. Sine is negative. So negative sine x, right? Dot. Cos of 180 plus x, 180 plus x, that's in the third quadrant. Cos is also negative, negative cos x. So now we can see we got 1, 2, 3, 4 negative. An even number of negatives makes it a positive. So we have some cancellation here. We got sine x and sine x cancels out, right? We just left with something over cos x. Now, how are we going to simplify that? All right, so what we have on top is all the negatives cancel out, by the way, right? So we have sine x, right, over cos x over here. See, we got sine over cos. I'm just collecting this together. That's sine over cos times negative tan times sine x over cos x. So what we were supposed to write it as was a single trigonometric ratio. So we're going to write this is tan x times tan x. So this is just basically tan squared x, okay? Because we need to write it as a single trigonometric ratio. So there's it here. So that's basically tan squared. I hope you understood that. Let me do the next question next to it. Now we're good. Understanding?
Yes.
Excellent. All right, so now next question. We have tan of 270 minus theta. Now, remember what I told you about using tan. What you're going to do is, okay, because we have plus on top and we have some kind of multiplication at the bottom, there's no plus there. Let's see what we're going to do. So I will reduce each one. Okay, so let's write this as tan is sine 270, sine of 270 minus x, 270 minus theta over cos of 270 minus theta dot, not dot, plus. What is sine of 180 plus theta? That's in the third quadrant and is negative. So negative sine theta, right? All over. What is cos of 360 minus theta? That is in the fourth quadrant. So you just cos theta. Sine of 90 plus theta, that is in the second quadrant. But in the second quadrant, sine is positive. So just positive. So that just give you cos theta, right? So far so good. Let's see if anything, if there is a cancellation there. So what we have here on top is sine of 270 minus theta. We're also dealing with 270 here now. So that will be in the third quadrant. Sine changes to cos theta. Cos of 270 minus theta. Sine of 270 minus theta is in the third quadrant. And in the third quadrant, sine is negative. So you need to have a negative there. Cos of 270 minus theta is in the third quadrant, is also negative and changes to sine theta. Guys, I think there was no plus. There should have been multiplication. All right. Should have been a times. All right. So times negative sine theta, right? Over cos theta, cos theta. Now, we can see that negative sine theta cancel out. So remember, there was a plus there, change it to times. Negative sine theta cancels out. Remember now what we are left with. There's nothing here. So it's like dropping that numerator down back here. So we can also cancel out one cos with another cos. So we can cancel out that cos theta and that cos theta. And the negatives cancel out. Everything on the numerator canceled out. So the answer is just 1. And we're just left with cos theta. So just 1 over cos theta. If you want in IB, you can write this out as sec theta, right? But there's no need in NSC to write, right? This is the full form for this is cosine theta, 1 over cosine is sec theta. So no need for that. If you stop here, it's fine. Right, I'm going to solve these quickly because we need to move on to the next part. Right, so next part we have sine of 540 minus alpha, sine of 540 minus alpha. Now remember this angle is way more than 360. All right, so I'm going to remove a revolution. So take away one revolution. So minus 360, right? Now, when you have multiple step procedures, I would suggest make this equal to the answer, right? Make this entire thing equal to A and reduce each one. Say sine of 540 degrees minus alpha is basically equals to sine of, take away 360, I think you will get 180 minus alpha. And sine of 180 minus alpha, that's in the second quadrant, that will just be sine alpha. Next one, we want to reduce cos of 270 plus alpha. That's in the fourth quadrant, and we are using 270. So just sine alpha. And then we want to reduce tan 180 plus alpha. That's in the third quadrant. That is just tan alpha. Remember to write it out. Tan of 180 plus alpha. That is just equals to tan alpha. And tan alpha is sine alpha over cos of alpha. Sine over cos of the angle. Now it's easy. We can just say this entire thing, I call this entire thing equals to A. So we can just say answer is now equal to sine alpha, the first part, times, what's the next part? Also sine alpha, right? Divided by sine alpha over cosine alpha. So what do we have here? We have sine alpha times sine alpha divided by, so multiplied by cosine over sine alpha, right? So because we are dividing it by this fraction, so we need to change the fraction, right? If we're changing to multiplication, right? So we can see now the sine alpha and the sine alpha cancel out, right? And now we are left with sine alpha cos alpha. Well, I can't do anything, just leave it like that. You didn't learn sine alpha cosine alpha, right? If you have done double angle, what you would have done was you will multiply by 2 times half, make it into 2 times half is 1. And then you know that 2 sine alpha cosine alpha is sine 2 alpha is a double angle. We'll do that just now. Half sine 2 alpha. So that's like writing it in terms of a single trigonometric ratio. That's our next part to learn. But if you leave your answer as, you shouldn't leave your answer like that if there's a single trigonometric ratio, right? Next one. Right, so I want to simplify 3 sine 150 cos 300, right? So I'm just going to make this equals to answer, and I want to simplify each one. What is sine of 150? So I'll say sine 150 is equal to, that's in the second quadrant, right? Because it's the same thing as saying sine of 180. How will you get 150 using special angles? 30 degrees. 180 minus 30 is 150. Actually, nothing. And 180 minus, think of 30 degrees as theta. 180 minus theta. So what is sine of 180 minus theta? It's in the second quadrant. So it becomes sine theta. So sine of 30 degrees. If you use your calculator, you just get half, right? Next one. That's a special angle, all right? There are 5 special angles: 0, 30, 45, 60, 90. Cos 300. Right, so what is cos of 300? Let's rewrite cos 300 as, cos 300 will be cos 360 minus 60. So that is in the fourth quadrant. That will just be cos of 60. And cos of 60 is also half. Great. So we have both. Next part is the denominator part, tan 225. So that's tan 180 plus 45, right? And that's in the third quadrant, which is tan 45, right? And tan of 45 is just 1. See how nicely everything simplifies. And the last one is sine of 330, which is sine 360 minus 30, right? And sine of 360 minus 30 is in the fourth quadrant, so that's negative sine 30, which is negative half. Now I'm going to put the answers here now. This answer is now equal to, that was half, so 3 times half times another half divided by, see, I did all my calculations on that side. See, all the answers are here. Tan 225 is 1. Sine of 330 is negative half. Okay, so I'm going to cancel out negative half and a half. Right, so, and I have 3 times half, which is, I can't cancel out the negative half and a half. It's just half and a half. The negative still remains. So my answer is negative 3 times half. Everything canceled out on the denominators. There's nothing left. So negative 3 over 2. Right, so that's my final answer. Move on to the next question. Just 1 second. Right, so next question, question number 5. Just want to finish this up quickly. Right, so I showed you a trick on how to go about solving this. Next one, we'll do the same thing here now. We'll work out all the answers in the side. So what is cos of 240? Cos of 240 is cos 240, which is cos of 180 plus 60, right? Which is third quadrant, negative cos 60, which is negative half. Can use your calculator there or the special triangle. Sine 315, which is a sine of 360 minus 45, which is negative sine 45, because that is in the, which quadrant is that in? Fourth quadrant. Sine is negative. So you will get negative 1 over root 2. Let me leave it like that. I can show that. You can also show the rationalization, multiply by root 2 over root 2 and make it negative root 2 over 2. Okay. So you can show the rationalization there. You can use either or if you show the rationalization. A little bit more towards the side so you can see. Right. Next one. Tan 135. So we have tan 135. We can change it to tan 180 minus 45. Anything that ends with a 5, you've got to use a 45 there, okay? So now we are in the second quadrant. So negative tan 45, because 180 minus, which is negative tan of 45 is 1. That's easy, right? And the last one is sine 210. Sine of 210. That is sine of 180 plus 30 degrees, which is negative sine 30 degrees, which is, because it's in the third quadrant, and which is negative half. Right, so now we have all the values. We can just substitute here. So we have negative half. Sine 315 was negative root 2 over 2 plus 1 divided by negative half. Now remember, you can't cancel because you got a plus there. It's a problem. right? Now, let's see what we have. Negative half times negative root 2 over 2 is just negative root 2 over 4, right? Plus, you can change the 1 as 4 over 4 because I'm doing the numerator first. Change the 1 into 4 over 4 because we got LCD, which is 4 here, right? And remember what we are doing, we're dividing it by negative half. So we just need to do basic algebra. 4 times root 2 is 4 root 2. And no, we're not multiplying. Sorry, we are adding, we said. 4 plus root 2. We're adding those two, right? That was correct. 2 times 2 is 4. We're adding them up. Right, so 4 plus root 2 divided by 4 times 2 over 1 because you're flipping that chain, keeping that negative there. Right, so the 2 and the 4 cancels out once and twice. So now I have an answer which is equals to negative. Still have to multiply this whole thing by a negative 4 plus root 2 all over 2. But now if you're going to take the negative inside, it's going to become negative 4 negative root 2 over 2. So I think you'll keep your answer like this instead of that, right? Yeah, don't worry about the last part. Let's take that out. And one last question, quickly. Now, in the last question, there's something very important that I wanted to cover, right? Note that what you find, what you will find in most cases is of these types of problems, you will be given a co-ratio problem, right? Example, what do we know about sine of 30 degrees? So we know the sine 30 is cos 60 because both the values are exactly the same. It is half. We also know that cos 30 is equal to sine 60. And we know that both of them are root 3 over 2. So in general, what we can say is that as long as those two angles add up to 90 degrees, right? Then I can always have cos on one side and sine on the other side because that's how co-ratios work. So if I ask you what is cos of 10, cos of 10 is the same thing as saying sine 80, right? If I ask you what is cos of 5 degrees, cos of 5 degrees is sine 85, right? Because of co-ratio. So remember these. So similarly, same thing, that's the reason why we say sine 45. Obviously, if I put sine 45, 45 plus 45 must be 90, right? So now on the other side, it has to be cos 45. So these are just some tricks of co-ratios. We might use it here or we might not. Let's see, we have 495. If you take 360 away from 495, what do you get? Do we have anything? Let's see. 495 minus 360. Right, so we're getting 135. Yep. Yeah, we are getting 135. So let's try to simplify each one. This is equals to some answer. Sine of 495, right? Sine 495 was 495, right? Is equal to sine 135. So we brought it down by taking out one revolution minus 360, right? So that's 135. That's in the second quadrant. So that is sine of 180 minus 45, right? Which is sine 45. And sine of 45 is basically equals to, that's in the second quadrant, it is 1 over root 2. Remember what that is? I'm just showing you the detail reduction, right? What you can do is you can go directly from sine 135 to sine 45. don't need to show this step, right? So let us not show that step because we know what we are doing. That's in the second quadrant, right? So I'm not going to show that step now because we kind of like mastered what to do. So let's not show that step and we can go directly there, right? So sine 135 is sine 145 and sine of 145 is sine of 45 is basically is in the second quadrant. Remember, sine 135 is in the second quadrant, is positive. So that's how we got sine 45, which is 1 over root 2. Multiply by root 2 over root 2. We get root 2 over 2. Right, so that's sorted. Next one. What is cos of negative 120? Cos of negative 120. You have two options. You can use a negative angle theory. Yeah, that's already in the fourth quadrant, right? Yeah, that's the thing about negative angles. If you're going to treat the entire thing as theta, then you're going to say, okay, negative angle. Otherwise, I would suggest whenever the angle is negative, just add a 360. It'll make life easier. So that becomes cos 240 because 360 minus 120 is 240 degrees. 240 degrees is basically in the third quadrant. So that's negative cos 60. I hope you understood where the negative came from because the 60 degrees is the reference angle, right? It was 180 plus 60, right? 60 degrees is the reference angle and cos of 60 is half, right? Next one, tan 570, tan of 570. If we take away one revolution from here, 570 minus 570 minus 330 degrees, we are getting 240. So we're getting tan 240, which is equals to, that's in the third quadrant. So tan is positive. So tan 60, right? And if you type tan 60, you'll just get root 3, I think. Tan 60 mode. Degree mode. Make sure the calculator is in degree mode. Tan 60. Right. So I'm getting root 3, or you can use your triangles to solve, right? Then sine of 750. We're going to minus 2 revolutions, right? Sine 750. We're going to minus 2 revolutions, okay? Minus 2 times 360. So we're going to minus 720. So you'll just get sine of 30 degrees, which is half. 750 minus 720. And then the last one is cos of 45. Cos of 45 is just 1 over root 2. Multiply by root 2 over root 2, you get root 2 over 2. So now therefore, your answer is now equals to, what's sine 495? Root 2 over 2. What is cos of negative 120? That's negative half. What is tan 570? That's root 3. And we're dividing, what sine of 750? That's root 3. Sine of 750, that's half, right? And then cos of 45 is root 2 over 2. Now you can clearly see that root 2 over 2, root 2 over 2 cancels out. You can clearly see that half and a half cancels out. And my final answer is negative root 3. Negative square root of 3. Right, so guys, this completes our first part of trigonometry, which is, what is this? We just did a reduction formula using 180, 360, 90, and 270, right? And special angles. So that's what we have done, right? So this is horizontal reduction. This is vertical reduction, right? So this is where 90 and 270, and we have done special angles. Now we're looking at compound. I'm going to do compound angles and double angles together, right? So let's focus on that now. And then we can answer some questions. Compound angles and double angles. Right. Now remember, these formulas will be given to you. There's no proofs required. The only proof that is required is using one of the formula, you must prove the other. Right. So all we know is that cos of A minus B, right? Cos of A minus B is equal to cos A, cos B. If you take the difference between two angles, cos A, cos B, plus sine A sine B. Okay. Now, this is the formula for expanding cos when there is a difference. Now, what happens if there is a plus? If there is a plus, then this part will become a minus, right? Example, what is cos of A minus B? Cos A cos B minus sine A sine B. And then what is sine of A minus B? For the sign remains the same. You start with sine, end with sine. So this is sine A. These are all compound angles, by the way. Sine A, and you're going to put sine B last. And then you're going to change this to cos A, sine A cos B minus cos A sine B. For sine, the sign remains the same. See here. Start with sine and end with sine. Then for what is sine of A plus B? That is basically sine A cos B plus cos A sine B. So remember, the plus remains a plus. Just cos compound angle, cos A minus B is cos sine sine. Now, what if the types of proofs that you will be given is something like this? Given that if you are given cos of A minus B, right? If you are given cos of A minus B is equals to cos A cos B plus sine A sine B. Using that, find the formula for sine A plus B. What if they tell you that? Using this information, find sine of A plus B. Now what you're going to do? To find A sine of A plus B, you got a problem, right? Because I need to come up with this formula at the end. So I can use cos of A minus B to manipulate any one of these formulas. I can come up with any one of the formula, or I can be given any one of them to find any one of the other, right? So I want to find sine of A minus A plus B. So what's my solution here? I would say sine of A plus B is actually equals to cos. I'm using co-ratio now. What is sine of theta? Cos of 90 minus theta. So I'm going to use this 90 minus A plus B. So I hope you understood what I have done here. So it's like taking this entire thing to be theta, because I need to change the sign. I need to incorporate this formula here. I need to use this formula somewhere here, right? So I need to use cos A minus B formula. So that's what information I have. So I need to use this to expand sine of A plus B. So sine of A plus B is cos of 90 minus. How we know that? Because we know sine theta is the same thing as saying cos of 90 minus theta. Remember, the sum of these two angles must be 90. And if you have sine and cos mixture, right? That's how co-ratios work. Remember, the sum is equal to 90. So now we have this. So let's separate it into this form. So now we have cos of 90 minus A minus B. And guess what? We have it in this form now, because I can call this part alpha and I can call this part beta. So let's use this information here now. I can change it to x and y, right? See, A minus B. So now I have this form. I've got this form, A minus B. So your A is like your alpha, right? And your B is like your beta. So there's a first angle and there's my second angle. Isn't this is my first angle and that's my second angle? First angle is A, second angle is B, and there's a negative there. So I can use this formula. So that's what I'm trying to do here. This is my first angle, that's my second angle. So what's the formula? Cos of something, cos of B plus sine of something and then sine of b. What did I do? I had a b there, so it's fine. So what's your a, like your alpha here, which is 90 minus a, right? 90 minus a. What is this? 90 minus a, right? That's your first angle. Now simplify. We got cos. What is 90 minus a? Again, reduction. That's why reduction is very important. That's why I taught you reduction first. So when I go into compound angles, you will understand everything. Okay. So what is 90 minus a? It's in the first quadrant, cos changes to sine. So now we have sine a, cos b. What is sine of 90 minus a? Cos a, sine b. So my question is, did we come to the formula? Yes, we did. Because I asked you what is sine of a plus b. Sine of a plus b is sine a cos b plus cos a sine b. So everything works. Are we good? Right enough? So I can take any of these formulas to manipulate the other. So it becomes very simple. Make sense, guys? You'll see more examples like these. Mishka, we good?
Yeah, so can you actually like, I don't know, the last part?
Yeah. Cos of 90 minus a. This part here?
Yeah, that the green step.
Yeah. So the green step, what we did was we used cos of a minus b. Look at the form. The information given was cos of a minus b is cos a cos b plus sine a sine b. I would define sine of a plus b. So first you use a co-ratio, then you expand it. So this is the first angle and that's the second angle. So the first angle is what? 90 minus a. First angle. So cos of first angle, think of this as first angle, second angle. So it's cos of first angle, cos of second angle plus sine of first angle, sine of second angle. So cos of first angle is 90 minus a. Cos of
Then
second
why
angle is
did
cos b.
you, when
Yeah.
you're doing like the, why didn't you add a negative b? Why is it just b?
Yeah, there's no negative b because it's the formula. Cos of a minus b is cos plus sine.
Oh, so you just make it to how the formula is.
Yes, that's correct.
Okay.
Hmm. There's no negative. Look at here. What you're asking me is something very important, and 99% of students make a mistake. See, you have cos of a minus b. So we didn't put a negative b because according to formula, it's just say cos a cos b plus sine a sine b. Okay, so there's no negative there. Right, so good. So now we reduce 90 minus a to sine a and sine of 90 minus a to cos a. So we got sine a cos b plus cos a sine b. Great. Guys, let's look at some questions based on this compound angles. Then we can do double angles. Right, so this is our question 7. I got two parts here, part A and part B. Okay, so see what this here says. Expand the following. Expand cos of A minus 50. That's easy. Cos of A minus 50 is cos A sine 50. No, it's cos minus sine. No sine here, sorry. Cos sine. So it's cos A cos B, which is 50, plus sine A sine 50. Now 50 degrees is not a special angle, so we keep it like that. Okay. So it's direct application of the formula. Remember, these are your formulas. Right, so I'll paste it here, keep on pasting it here, right? So let's see. So remember what we wanted? We wanted to know what is cos A minus B. So cos of A minus 50 is cos plus sine. Let's look at the second one. Now you must not only expand, you must expand and try to simplify as well. When will you simplify? When they are special angles. So let's look at this B, second part of the problem. It's not over, it's part B, right? I want to expand sine of 3 beta plus 45. Sine. So you're going to say sine 3 beta and it's going to remain with a plus, right? And you're going to end with a sine 45. Start and end with sine And then in between, you put the causes in. Cos 45, right? And cos 3 beta. Are we good? Now we can't do anything with the 3 beta, but cos of 45 is 1 over root 2. So sine 3 beta times 1 over root 2 plus cos 3 beta times 1 over root 2. Now guess what? We can take out the 1 over root 2 as a common factor. And we can say sine 3 beta plus cos 3 beta. All right. And we can change the 1 over root 2. We can say multiply by root 2 over 2 to root 2 over 2 into sine 3 beta plus cos 3 beta. What have I done here? I just use a formula directly. What is sine of a plus b? Sine, cos, cos, sine. First angle, second angle. Okay? There's your first angle, there's your second angle. There's your formula. Remember what your formula is. If you can expand this, it's sine A cos B plus cos A sine B. What's your B? 45-degree angle. And what's your A? The 3 beta angle is your A. That's what we are doing. So that's your final answer. Moving on. Now, you must look at the expanded part and you must also be able to contract, right? You expanded those. Now, this is already expressed the following as a single trigonometric ratio. This is already the expanded part. You must be able to contract, right? So I'm going to copy this formula here and see which one this here matches with. So we got sine and cos mixture. Because we got sine and cos mixture, not cos, cos, sine, sine. Because we have sine and cos mixture, it has to be a sine, right? And the sign remaining the same, it means there's a minus there. So it has to be a sign. So this is just basically sine. Okay. Remember the formulas are here. Check the formula. So this here has to be sine. Starting with sine, ending with sine. There's a minus there, cos x, cos. So it has to be sine. Sine of 30 degrees minus x. Right, guys? Sine of 30 minus x. Yeah. Any questions? No questions. Excellent. Let's look at part B. Now, looking at the same thing, use the formula to compact this notation, right? This is the expanded form. So use the formula. So cos, cos, sine, sine. It has to be cos, all right? Cos, cos, sine, sine. So, and there's a plus there. So it's going to become minus. See, plus becomes minus. So it's just basically cos 7 theta minus 5 theta. 7 theta minus 5 theta is 2 theta. Cos of 2 theta. Right, so that's your answer. See, there was a plus here and it's cos, cos, sine, sine. Cos, cos, sine, sine with a plus is cos A minus B. So 7 theta is your A and 5 theta is your B. So A minus B, right? So we know how to expand, we know how to contract. When do we usually contract in this case? You usually contract in this case is when you are solving trig equations. It's very important to know how to contract. You contract them to find when you have trigonometric equation. At the moment, we are just learning how to simplify, right? Next. Look at question number 9. Express the following as a single trigonometric ratio. So we got sine 25, cos 35. So we got sine, cos, cos, sine. Okay, so that is easy. That has to be sine, all right? Sine, cos, cos, sine. Sine, cos, cos, sine. And because it's plus there, it has to be sine with a plus. So we just need to add up those two angles, 25 plus 35. And what's 25 plus 35? That is sine of 60. Aha, and sine of 60 is a special angle. So that answer, this write it as a single trigonometric ratio or simplify. I'm just simplifying fully. We wrote it as a single trigonometric ratio, which is sine 60. But now I'm going to simplify sine of 60, which is root 3 over 2. You should simplify actually. So that would be the correct answer. Look at the next part. Same story here. Shouldn't be writing express the following as a single trigonometric ratio. No, single trigonometric ratio and simplify. Right? Right. So sine, cos, sine. So starting with sine, ending with sine, there's causes in between. It has to be sine. All right. So sine of 110 minus 50. All right. So that also works out to be sine 60, which is great. Sine of 60 is again root 3 over 2. Right, so we just wrote it in two different forms. Right, good stuff. Now look at these types of questions now. Calculate 15 degrees without using a calculator. Now I wanted to touch on something very important because you know the special angles that we have. From special angles that we currently have, and using these formulas, you're going to get more special angles, right? Using the compound angles, you're going to end up with more special angles. So remember, if you use 30, if you use a 30, 45, and 60 degree, right? Using these things, you're going to end up with more special angles. Like you can take 60 minus 45 to get 15, right? You're going to get more special angles by adding and subtracting them. So 60 minus 45 is 15. You can also get 45 plus 30, which is 75. These are special angles created from, further special angles created from compound angles. And you can also get, adding 45 and 60, 105. Okay, so these are three more special angles that you can get from further. So what do we want to find? We want to find cos of 15. Right, so what is cos 15 degrees? Cos of 15 degrees is clearly taking 60 minus 45 or 45 minus 30. Let me take 45 minus 30. Right, 45 minus 30 degrees is 15. Now what is cos of 45 minus 30? Cos of a minus b is cos plus sine. Okay, so I use that formula directly in here. Now remember, you're not allowed to use a calculator. So what's cos of 45? 1 over root 2. Cos of 30 is root 3 over 2. Sine 45 is 1 over root 2. And sine 30 is half. So what I'm going to do is multiply this by root 2 over root 2. Multiply this by root 2 over root 2. So we're going to change everything now, LCD. We will have root 2 over 2 times root 3 over 2 plus root 2 over 2 times a half. Now it's easy because we got root 2 times root 3, which is root 6, rule of surds. If you have root a times root b, get square root a times b on the inside. Now root 2 times root 3 is root 6, and then 2 times 2 is 4. Root 2 times 1 is root 2, and 2 times 2 is 4. Now we can just add the numerator, which is root 6 plus root 2 all over 4. Now, if you type cos 15 in the calculator, you have to get this final answer over here. You must get it. So let's type cos 15 to double check. Cos 15. Root 6 plus root 2 all over 4. So we are getting the answer. Now you can work out any one of these angles with either with the sine or with the cos, whether it's 15 degrees, whether it's 75 degrees, or whether it is 105 degrees, all created from the special angles 30, 45, 60. Okay, I didn't put 0 and 90 there because it's not important. Right, Arnav, we good? You understanding everything so far? So I taught you how to expand using the compound angle, showed you how to contract, showed you how to use create further special angles, right? So you can get questions like these in your exam without using a calculator. Arnav, we good?
Yes.
All right, excellent. Let's look at more problems here. See what he's saying. Expand alpha plus 10, alpha plus 60. How are we going to expand that? Right, so this is an expansion of special angles with that. Look, to do this, we're going to say sine over cos. You have to say sine over cos because you don't have a formula for that. So you're going to say sine alpha plus 60 divided by cos alpha plus 60. So all you're doing is you wrote it as sine over cos. Now you need to expand this. Sine alpha cos 60 is a sine, because you're expanding sine. It's sine and cos mixture plus cos alpha sine 60. So start with sine, end with sine, cos 60, cos alpha, all over cos minus, because there's a plus there, sine sine. Right, so now we got sine alpha, it remains sine alpha, right? Times cos of 60 is half, plus cos alpha remains cos alpha. Sine 60 is root 3 over 2 divided by cos alpha times cos of 60 is also half, plus, no, there's a minus here, minus sine alpha sine 60, which is root 3 over 2. Right, so guys, what are we going to do here now? How are we going to simplify this? Okay, to simplify this, I want to get rid of this numerator denominator half. So I'm going to multiply the numerator by 2, and I'm also going to multiply the denominator by 2. Each term on the numerator by 2, and I'm going to multiply each term on the denominator by 2, so all these fractions can disappear. Right, so sine alpha, half sine alpha times 2 is just sine alpha. You're allowed to do that. Whatever you multiply on top, you must multiply the denominator as well. Sine alpha plus root 3 plus root 3 cos alpha divided by cos alpha minus root 3 sine alpha. Right, and that's my answer. Right, so I'll leave my answer like that. Yeah, that's the expansion for tan alpha plus 60. That's what it is. Right, I'll leave the answer like that. I will not proceed further with this problem. Okay, I'm not going to do 90 minus 2. That's too easy. Should have done 30 minus 2x. Because 90 the sine of 90 minus 2x will just be cos 2x, because it's in the first quadrant. We are using 90. That's a reduction angle. So I change it to 30 minus 2x. So sine of 30 minus 2x will be sine 30 cos 2x, minus remains minus. Remember, we have to use these rules to expand. Sine of a minus b, sine a cos b minus cos a sine b, minus cos a, which is 30 sine 2x. There's no distribution like this. You're not doing things like this. Multiply there, multiply with there. No, no such thing, right? You're using the compound angle to expand. So you're using these rules to expand. And these rules can be proven from geometry. We use distance formula and cosine rule to prove cos of a minus b is cos a cos b. There's no need for the proof, right? That's the reason why I didn't do it. It's not examinable. Anyways, what is sine of 30? Sine of 30 is half. Cos 2x remains cos 2x. Minus cos of 30 is root 3 over 2. Sine 2x remains sine 2x. Okay, and I will just leave my answer like that for now. And that's my expansion. Yeah, that's great. Moving on to the next question, which is question 12. Express as a single trigonometric ratio and also simplify, right? And simplify thereafter. Why we say and simplify? Because we only have numbers here, right? Now see what's happening here. We are starting with sine 80 and we have cos 20, cos 80, sine 20. So it has to be a sine problem. So it's going to be sine 80. There's a minus there, right? So minus 20. Again, it's sine 60. Sine 60 is root 3 over 2. Did I write sine 60 as root 3 over 2 before? Yes. Okay. All right. Perfect. Right. So guys, that is basically compound angles, using how to use it, expand, contract. Obviously, we'll be using these later on in trig equations and identities and 3D problems and stuff. Right. Next part, we just did we just did compound angles and double angles. Let's look at double angles now. So what are double angles? Double angles, very simple, is we want to know what is cos 2 times the angle. That's a double angle, 2 times angle. What is cos 2 times angle? Very easy. We can say that is cos A plus A, okay? We can just use a compound angle. And what is cos A plus A? Is cos minus sine, right? Because both A and B are the same. It is A. So what is cos sine? Cos squared A minus sine squared A. Aha. So cos squared minus sine squared is cos double angle. So this implies cos of double angle is always cos squared A minus sine squared A. Now guess what? Let's substitute sine squared A. Let's substitute our identity in sine squared A. So we can say, okay, sine squared A is equal to 1 minus cos squared A. So let's put that in here. 1 minus cos squared A. So this is cos squared A minus 1 minus and minus makes a plus. I'm opening the brackets up. So I replace sine squared A with 1 minus cos squared A. So I've got cos squared A. So cos squared A plus cos squared A is 2 cos squared A minus 1. So this was my first identity. This is my second identity. Now, what if, remember, cos 2A is also equals to, it is equal to cos squared minus sine squared from compound angle, right? And now I want to replace cos squared A with 1 minus sine squared A. Where am I getting this from? Cos squared plus sine squared is 1, right? So this is 1 minus sine squared A minus sine squared A. So we got 1 minus 2 sine squared A. So there's my third identity for double angle. So there are three different double angles for cos 2A. Cos 2A is equals to any one of these three. Cos squared minus sine squared is also equals to 2 cos squared A minus 1, right? So I just like to remember the first part, okay? I like to remember the first part and I use 1, 2, 1, 2 method. So I'll put a 2 in the front and make that into a 1, the second part, or make this into a 1 and put a 2 in the front. 1, 2, 1, 2 method, right? So 1 minus 2 sine squared A. Okay, so those are the three double angle for cos. So what's the double angle for sine? So we have sine double angle, which is sine A plus A. And that's easy because this is just sine A cos A plus cos A sine A. And both of them are identical. So it's just 2 sine A cos A. And we only have a single identity for sine, right? So this is your identity for sine double angle, and these are the three identities for cos double angle. So this implies, let's write down sine as well. 2 sine A, cos A. So these are the ones that you need to know, including the compound angles, right? So how many you got here? 1, 2, 3, 4, and 4 compound angles. That makes it 8. 9 is the square identity. Sine squared plus cos squared is 1, and 10 is equal to sine over cos. So those are the 10 identities that you got to know. But obviously the formulas will be given. Besides for 10, I think 10 is not given. Sine squared plus cos squared equals 1. That's not given because that is kind of like trivial. So you got to know those things. So you got to remember, even these formulas are given, but you need to know which one to exactly use, right? So these are all the double angle formula. Let's look at some examples on double angles. Right, so expand the following using double angles. So we want to expand using double angles. Let's see. Sine 50. Sine 50 is the same thing as saying sine 2 times 25, right? And what is sine of 2 times 25? 2 sine 25 cos 25. That's it. So what is, this is sine 25 cos 25 with a 2 there. So that's sine 50. That's direct application. Let's have a look at this one because this here also came out in past papers in the exam. So cos 3 theta, right, in terms of cosine. So you need to write everything in terms of cos. Let's see. First, we're going to expand cos 3 theta as cos uh, 2 theta plus theta, right? And then we'll use a double angle. So 2 theta plus theta, that is the expansion for cos. Now, how do we expand cos? Remember, this is not a double angle as yet. We have compound angle here. This is like cos A plus B. What is cos A plus B? Cos A, cos B, cos minus sin. Cos A, cos B minus sin A, sin B. So that's what we're trying to do here. So that will be cos 2 theta, cos theta minus sin 2 theta, sin theta. Okay, now let's look at this. There, we have a double angle here, but now you need to expand the double angle in terms of cos only. See, right, in terms of cosine. So cos 2 theta is which one? Which one should I use from here now? Yes or no? We're going to use the second one, right? Because we want in terms of cosine only. So 2 cos squared. So what is cos of double angle? This is 2 cos squared theta minus 1 times cos theta minus, what is sine 2 theta? 2 sine theta, there's only one double angle for sine, cos theta times sine theta. Now, expanding the first part, we got 2 cosine cubed theta minus cos theta times -1 is how we got cosine cubed. 2 cosine squared theta times cosine theta is cosine cubed. Cos theta times 1 is cos theta minus 2 cos theta times sine squared theta. Remember, all this is multiplied by each other. So I'm just writing it in order. Sine times sine theta is sine squared. I'm just rearranging it. I'm putting sine squared at the end. But we don't want any sines. We only want cos. But we know sine squared is 1 minus cosine squared theta. So 2 cosine cube theta minus cosine theta minus 2 cosine theta times 1 is minus 2 cosine theta minus 2 times plus, so plus 2 cosine cube theta. So we multiply everything out here. 2 cosine cube plus 2 cosine cubed is 4 cosine cube theta minus cos theta minus 2 cos theta is minus 3 cos theta. Right, so I hope you understood that. We use double angle and compound angle in this example. We kind of like mixed both because cos theta can't be written as a double angle. It can be written as a double angle plus a single angle, 2 theta plus theta. We got to use the compound angle first and then apply the double angle technique using any one of these formulas to expand everything. So I hope that made sense. Let's look at the next problem. Won't be so difficult now, much more easier than that. Right, so simplify the following using double angles. How are we going to simplify this? We got sine squared minus cosine squared. Sine squared minus cosine squared is nothing. But cosine squared minus sine squared is something. That's the double angle. Cosine squared minus sine squared. Look at this. Cosine squared minus sine squared angle is cos double angle. So we need to take out a negative and rearrange. So I took out a negative. So cosine squared 22.5 minus sine squared 22.5. Right, so now we got cosine squared angle minus sine squared of the angle. That is just basically cosine 2 times the twice the angle, which is 22.5, which is negative cos 45, okay, which is negative 1 over root 2 multiplied by root 2 over root 2, which will give us negative root 2 over 2. Right, so you got to rationalize and show that answer. You can type this into the calculator and check if we are getting the same thing. Of course, we are getting the same thing. Let's check. Sine squared. How are you going to type sine squared? You're going to say sine 22.5, right? And then squared like that. No, I think you should put a bracket as well. Put another bracket and then squared. Right? And then subtract cosine, put a bracket, cosine 22.5. That bracket is for the angle. That bracket is to close the cos squared. I'm getting negative 0.707. And that's was negative 1 over square root 2. Same answer. Next one. What is 2 cosine 15 sine 15? So that is a sine double angle. So that's easy. The sine, because 2 sine theta cos theta is sine double angle. So sine double angles 2 times 15, right? And that is just basically sine of 30 degrees, which is a half. Right, so I hope that made sense. Right, guys? Hope you guys are understanding. Next one. Right, so how are we going to solve something like this? Sine 75 plus cosine 75 all squared. Remember, now we have the knowledge of double angles and compound angles. We'll try to use double angles as far as possible. We try not to use compound angles. But if we are stuck, we will use a compound angle. So now let's simplify this. If you're squaring something like this, squaring a binomial, we know sine squared 75 plus what's the middle term? 2 sine 75 cos 75. So remember, a plus b squared is equal to a squared plus 2ab plus b squared. All right? So we got sine squared 75 plus 2 sine 75 cos 75 degrees plus cosine squared 75. Right? Now we know, we can see that we have an identity, cosine squared plus sine squared, okay? See? That's a square identity. What is sine squared plus cosine squared? That's 1. I'll write it out here. Sine squared angle plus cosine squared angle, that's equals to 1. So that is 1, right? What is 2 sine 75 cos 75? That is already a sine double angle. So that is sine 2 times 75. So lots of stuff happening here, right? So 1 plus, what is this? 2 times 75, 75 times 2 is 150. So sine 150. But now sine of 150 is in the second quadrant. So that becomes sine 30. Sine of 30 is half. And 1 plus half is 3 over 2. Right, so just check if this answer is also true. We can check it out with the calculator, right? Verify. Open bracket, what we have, sine 75, okay, plus cos 75, close another bracket, square it, square the whole thing. Yeah, 3 over 2 is the right answer. Let's look at the next problem. So we got sine 3 theta minus sine theta over cos theta minus cos 3 theta. Whoa, that's quite big, these problems. Writing it out like this. Okay, so let's see what we can do here. It's going to be quite long because now for 3 theta, we don't have a way to simplify that. How should we do this now? With cos theta minus cos 3 theta, sine 3 theta minus. Okay, I'm going to try and expand sine 3 theta here in the side. Sine 3 theta, we have to use the double angle. Sorry, we have to use a compound angle. Sine 2 theta plus theta. That is basically equals to sine 2 theta cos theta sine 2 theta cos theta plus cos 2 theta sine theta, right? That's what we have. And cos 3 theta at the bottom, that will expand to cos 2 theta plus theta. That's cos 2 theta cos theta minus sine 2 theta sine theta. That's going to be at the bottom. All right, so that's what we have on the numerator with a minus sine theta, and I don't know what this is going to simplify to, but anyways, let's check. So on the numerator, we got this part here. And we have a further minus, don't forget to minus the sine theta, right? And on the denominator, we got cos theta. I'm taking a minus inside here. What is cos 3 theta? All of this. So I'm going to take a minus in there already. So minus cos 2 theta, cos theta, plus sine 2 theta, sine theta. Now I'm trying to find a pattern here. What should we do? If I take a sine theta as a common factor on top, will that work? I will have cos 2 theta minus 1. Okay. I'm going to try and take out a common factor here. So I'm going to group this one and this one up and group that one and that one up. So let's see if we can do something here. So what we have is sine 2 theta times cos theta plus, let me group this one up, sine theta, take out sine theta as a common factor. We'll have to cos 2 theta minus 1 divided by, take out cos theta as a common factor here, and I'm left with 1 minus cos 2 theta plus sine 2 theta sine theta. Now, I want to know what is cos 2 theta minus 1. Note, cos 2 theta minus 1 is basically equals to, so I'm going to change the cos 2 theta in terms of a way the minus 1 can cancel out. So cos 2 theta will be 1 minus 2 sine squared theta, right? Minus 1. What is cos 2 theta? I expand the cos 2 theta in terms of the the third double angle, which is 1 minus 2 sine squared theta. Isn't that one of the expansion of the double angle? 1 minus 2 sine squared theta. Yes. Right. Now, see the 1 and the minus 1 cancels out, right? So if the 1 and the minus 1 cancel out, I just got negative 2 sine squared theta. And similarly, 1 minus cos 2 theta. So what will be 1 minus cos 2 theta? 1 minus cos 2 theta is the same thing as saying taking out a negative here and transforming like this. So it can't be a negative answer. It will be the answer with the sine squared theta. Right. So 1 minus 2 sine squared theta, what we can say here is that we can say 1 minus cos 2 theta is 1 minus 2 sine squared theta. 1 minus 1 cancel out, minus minus 1 is plus, so just 2 sine squared theta. Right, so I've kind of like simplified that. Now, what is sine 2 theta? Sine 2 theta is 2 sine theta cos theta dot cos theta. So I've expanded the first part, right? Plus sine theta. I know what this part is, negative 2 sine squared theta, sine squared theta, divided by cos theta times 2 sine squared theta plus, what is sine 2 theta? 2 sine theta cos theta times sine theta. Remember, we're just trying to simplify this. Now, the first part over here is 2 sine theta cos squared theta, 2 sine theta cos squared theta minus 2 sine cube theta. Yeah, 2 sine cubed theta. Yeah, that's what we have here. 2 sine theta. Yes. All over. I want to see if we can do something else with that sine terms. Cos squared minus sine squared. If we took a 2 sine theta as a common factor, we would have had cos squared minus sine squared. Anyways, it's fine. Let's continue here. Cos theta sine squared theta. 2 cos theta sine squared theta minus, no, plus 2 sine squared theta cos theta. 2 sine squared theta cos theta. Wait a minute. Look at the bottom. Look at the denominator. Sine squared theta, right? So we do have something here. This is like term, so that is just 4 there, right? Like 2 cos theta sine squared theta, 2 sine squared theta cos theta. I'm saying the same thing twice. So 4 cos theta sine squared theta. Right, so that's the denominator. What about the numerator? Could we have had simplified that in a similar way? Can we simplify that in a similar way? Oh, yes. We can take our 2 sine theta as a common factor on top, all right? And we left with cos squared theta minus sine squared theta. Right, so we're almost there. So now what we can say is that the 2 can cancel out with the 4 2 times. 1 sine theta and 1 sine theta can cancel out. So all we are left with is 2 sine theta cos theta at the bottom. Oh, okay, okay. I see where we're going with this. What is cosine squared minus sine squared? That is already a cos double angle. So what is the double angle? What is the angle? Not a theta. Cosine squared minus sine squared is cos double angle. And we got 2 sine theta cos theta at the bottom, which is sine double angle. Right? It's the same thing as saying 1 divided by sine 2 theta over cos 2 theta. So it was actually 1 over 10 2 theta, by the way. A little bit challenging, but remember what I said before is that cos over sine is cot 2 theta, right? And cot is the same thing as saying 1 over 10. So you can write this as 1 over 10 2 theta. So you can go directly from that step to that step. Okay. So this entire thing is just 1 over 10 2 theta. That's a nice problem. Okay. Yeah. So we're looking at that question. Yeah. We got 2 more easy ones. Let's look at question number 17. We got 2 cos squared 75 minus 1. This is straightforward 2 cos squared theta minus 1. It's a straightforward cos double angle. So cos 2 times 75, right? Which is cos 150, which is second quadrant. So negative cos 30, negative root 3 over 2, cos of 30. Okay. Next one, sine squared minus cos squared. Again, we got a problem. Sine squared minus cos squared, that's not a double angle, but cos squared minus sine squared is. So take out a negative and make it rearrange. Cos squared 67.5 minus sine squared 67.5. That's negative cos double angle 2 times 67.5. 67.5. 2 times 67.5. 135. Cos of 135. Now, cos of 135 is in the second quadrant, so we have another negative, negative cos 45, because 180 minus 45 is 135, the reference angle. And 2 negatives already makes a positive, and cos of 45 is 1 over root 2 multiplied by root 2 over root 2, which is root 2 over 2. We can type this entire thing into the calculator and see if we have root 2 over 2 or the decimal value of this. Last question on double angle. Right, simplify cos 2x plus cos x sine 2x minus sine x. Easy. Expand the double angles in terms of cos on top. So you got 2 cos squared, 2 cos squared x minus 1 plus cos x divided by 2 sine x cos x minus sine x. Now, why are we simplifying all these things? Because these are techniques for you to identify when solving, proving identities and solving equations. So over here, I'm not sure what to do on top, but for the bottom, maybe on the top, what we can do is we can take the common factor of cos x out. If I take out cos x as a common factor, I'm left with 2 cos x plus 1, and there's a minus 1 at the bottom, at the end. But now this is more complicated. So that's why I said, let's hold on with the numerator because maybe we expanded into the wrong double angle. Let me factorize the denominator because I don't know if this double angle, we use a correct one. Just hold on with that double angle. So let's try to factorize the denominator and then decide which double angle to choose. Then I'll put down the right one. That's the only place where you have to think is with the cos double angle because there's 3 of them. Which one should you choose? Cos double angle is cos squared A minus sine squared A. Then you got 2 cos squared A minus 1 and then 1 minus 2 sine squared A. So which one should you choose? I went and put the first one and then you can see it becoming a mess. So let's try to simplify the bottom first. So take out sine x. And what are we left with? 2 cos x minus 1. 2 cos x minus 1. Okay, so because we got sine and cos mixture at the bottom, we need to make a sine and cos mixture on the top. So cos 2x, I will expand in terms of cos squared minus sine squared, okay? Yeah, so I expanded the cos double angles in terms of cos squared minus sine squared. I included both. But now the problem is to simplify this now. How should we simplify this? We can write it out as a quadratic, which is cos squared x. We got minus sine squared x at the end and plus cos x in the center. Will this work? Factoring this out, will that work? Yeah, we have an issue here. We have a problem. Factoring. Let's see. Cos squared minus sine squared. Let's try the factoring. We're gonna have cos x minus sine x, cos x plus sine x. Not working. Cos x plus sine x. It's impossible to get plus cos x in the center. Supposed to simplify this, right? 2 cos x minus 1. No, I think there's a problem with this question here. I can fix it up. No. Yeah, this is not going anywhere. There might be a problem with this question. 2 cos x minus 1. Because you see, My idea was to cancel the 2 cos x squared minus 1 with the 2 cos squared x minus 1. 2 cos x minus 1 with this. Supposed to be like that. 2 cos squared x minus cos x. That's fine. I'm going to change this question. 2 cos squared x minus cos x. So 2 cos squared x minus cos x over sine 2x minus sine x, right? The denominator is fine. So you should have something like this. So there's nothing to do on the numerator. Factorize the numerator, cos x, left with 2 cos x minus 1. And then these can cancel out. And you can say cos over sine, which is basically 1 over tan x. All right, guys. Now, I just want to start briefly with the next part, right? I hope you have like 15 minutes, 10 minutes extra for me because this is vitally important, right? So, which is quadrants and triangles. What's quadrants and triangles is solving for the diagram in the appropriate quadrants, right? So let's look at quadrants and triangles, where to put your quadrants in. It's mostly revision, but we have to apply double angles and compound angles. So question number 19. If 13 cos theta is equal to -5 and tan theta is positive, right? Without using a calculator and with the aid of the diagram, calculate. So we need to put the diagram in the right quadrant first, okay? We can clearly see cos is negative. Now, how do you find the right quadrant? So this is cos. Cos is negative in the second and third quadrant, and tan is positive in the third and first quadrant. So you got the most amount of information here in the third quadrant. So you draw a diagram in the third quadrant. Now, when you're drawing a diagram, make sure you drop the perpendicular onto the x-axis. Right, your reference angle is from starting from there, right there. Dot inside, reference angle is theta. Now, remember what is cos theta? Cos of theta is adjacent of our hypotenuse, -5 over 13. So adjacent is -5. 13 is the hypotenuse. And the opposite will be the y value. So how do we find y? Y is equal to the square root of negative square root, okay? 13 squared minus 5 squared using Pythagoras. So that is negative 169 minus 25. Negative 140, square root of 144 is 12, so negative 12. So the value of y is negative 12. So I can take this out, and that's negative 12. All right, so that's what we solve for now. Right, so we basically solve for that value, which is negative 12. Now, let's answer these questions quickly, because these questions got to deal with not only the diagram, also compound and double angles. Right, so using this diagram that you drew. Now, where do you draw this diagram when you're solving the problem? You draw it in part A, okay? Right, so in part A of your answer, you will draw this diagram. Now, we want to find what is 5 tan theta. So that is 5. What is tan of theta? Opposite over adjacent. Tan is opposite, adjacent. Opposite is -12, and adjacent is -5. Right, so 5 and 5 cancel out. The answer is just 12. And the negatives also cancel out. See, that's why they said 5 tan theta. What is cos of 2 theta? Cos of 2 theta, you can use any one of the trigonometric double angles, all right? Any one of the double angles. So let me just use the first one. Cos squared theta minus sine squared theta, right? Which is, what is cos squared? -5 over 13 squared. And sine squared is -12 over 13 squared, right? So I've got 25 over 169 minus 144 over 169. So what's 25 minus 144? 25 minus 144 is 119, negative 119 over 169, and that's my answer. Just by using the diagram. Now, within that problem, you will also get problems like C and D, where you have to use reduction to simplify. And this is easy because, see, remember reduction we used before? Cos of 90 plus theta, that is in the second quadrant, and cos is negative. We are using 90 degrees, so it changes to sine. Negative sine theta, and that's negative. What is sine of theta? Sine of theta is from the diagram, minus 12 over 13. Negative, negative cancels out, so you just got 12 over 13. I hope you understood that. Sine of 270 minus theta. 270 is in the, and minus theta, right? So vertical reduction still. That's in the third quadrant. Remember, 270 minus theta is in third quadrant. That's 270 line here. Minus theta is in the third quadrant. So sine is also negative in the third quadrant. So negative cos theta. Why we change it to cos? Because of 270, vertical reduction. And cos of theta is negative 5 over 13. Isn't, what was cos theta? Cos theta was negative 5 over 13, which is correct. Negative, negative cancels out. The answer is just 5 over 13. Right, so I hope you guys understood that. So that question 19 is done. We have a similar problem to this. Question 20, I'll just draw one diagram, right, and answer all these questions quickly. It's not going to take us long. Right, so we got if 25 sine beta is equal to negative 7 and beta is between 90 and 180, determine, come on, man, they already give you the answer here now. They're telling you that beta is between, not 90 and 180, I made a mistake here. Should be positive 7, sorry, should be positive, yeah, right. So if there should be no sign there, just ignore that, should be 7, not negative 7. So what we have is sine beta is 7 out of 25, okay? And beta is not in the first quadrant, 90 to 180 is the second quadrant. So you'll draw a diagram in the second quadrant, because they're telling you exactly where beta is. So we'll draw my diagram here. Drop down the perpendicular. Uh, that's the reference, that's the beta angle. That's the reference angle. Adjacent opposite is 7. Hypotenuse is 25. If you solve for the adjacent, you will get negative 24. How we got negative 24? You're going to say x equals, it's on the negative side, all right? And please show all this calculation in part A, right? So you can say x equals a negative square root of 25 squared minus 7 squared. On the calculator, you will get straight away minus 24 because it's on the negative side. X is on the negative, right? Otherwise, if you're using Pythagoras, remember this is the Pythagoras formula. X squared plus y squared is equal to a squared plus b squared is equal to c squared, or x squared plus y squared equals r squared. Now, anyways, we got all those. What is tan of negative beta? Tan is in the fourth quadrant, so that's negative tan beta. And tan of beta here is opposite over adjacent, so negative 7 over negative 24. So just 7 out of 24. What is cos 2 beta? When you are using cos 2 beta in terms of diagrams like this with all the values given, always use cos squared minus sine squared because you get the LCD. Cos squared beta minus sine squared beta. So what is cos? Cos is adjacent of hypotenuse, 24 over 25 squared minus sine is opposite of hypotenuse, 7 out of 25 squared. 24 squared over the, I think 24 squared, 600, 576. over 625 minus 49 over 625, okay? Let's just check if 24 squared is 576. 24 squared, yep, and minus 7 squared. Right, so I'm going to get 527 on top because I subtracted those two, and denominator you can't subtract, obviously. So that's 625. Keep the denominator. That's your answer. Next one. What is sine beta plus 30 degrees? Now you got special angles mixed with this, so you got to use a compound angle here because beta plus 30 is a compound angle. So you're going to say sine beta cos 30 plus cos beta sine 30. Sine of beta is from the triangle, from the diagram, from the cos diagram, sine of beta. So that's opposite over hypotenuse 7 over 25 times what's cos of 30? Root 3 over 2 plus what's cos of beta? Negative 24 over 25, right? And what's sine of 30? Half. So you can clearly see the denominator is 7 root 3 over 25 times 2, which is 50. Subtract 24 over 25 times 2 is 25. So my final answer is 7 root 3 minus 24 all over 25. And I think you've got to keep your answer like that because no calculator. They said with the aid of a sketch and without the use of a calculator. So this is your answer. Right, last part, guys, which is dealing with a triangle, general triangle, not in the diagrams, just drawing a general triangle, which is like in the first quadrant, just drawing triangle type questions. So what do we do in that case? You need to write your answer in terms of t. Very, very important. We'll solve this in 10 minutes, all right? And then you can leave. Right, so sine 42 is equal to t. Now, whenever a problem like this is given, you need to make it over 1, okay? So that's t over 1. It's just a basic diagram question, right? So we're going to draw the diagram for this, t over 1, and then solve everything else. So sine 42, we put 42 degrees here. And what's on top? 90 minus, make sure that triangle is complete. 90 minus 42. Okay. And 90 minus 42 is 48. Right? So the triangle is complete. Now, opposite hypotenuse. Opposite is t, hypotenuse is 1, and the adjacent will be hypotenuse minus the opposite square, so 1 minus t squared. So there's opposite, depends with which reference angle you're finding opposite adjacent hypotenuse, right? So now question 1. Yeah, I'm just doing one question on this, right? So A, B, C, D, E. Very important question, and it comes out in every single past papers. Right, so we want to solve what is tan 48? Question 1. What's tan 48 from this diagram? Okay, we have a diagram here. We're going to find what is tan of 48. Right, so what's tan 48? There's 48 degrees here, SOHCAHTOA, right? We're always using SOHCAHTOA from this triangle. SOHCAHTOA, so opposite over adjacent. So square root 1 minus t squared over t. Right, that's what tan 48 is. Square root 1 minus t squared over t. What is sine of negative 132? Sine of negative 132, we're going to take out a negative, right? Not take out a negative. This is in the fourth quadrant, so it becomes negative sine 132. Right. Now, to get 132, you have to say 90 plus. I think it's 90 plus 42. Yes. Yeah. 90 plus 42 is 132. But now we have 90 plus. 90 plus means Man, you don't need to do 90 plus. Try avoid using 90 plus and stuff. Use 180. Sine of 180 minus 48. 180 minus 48 is 132. And sine is in the second quadrant, so that becomes negative sine 48. And what is sine of 48? Opposite of our hypotenuse, just square root 1 minus t squared over 1. Right, that's it. Square root 1 minus t squared over 1. I'm not going to write over 1, okay? Because that's the denominator. You don't need to write it over 1. Next one. Looks like this question is repeated. That was sine 84. Okay, next question, sine 84, yes. Right. Next one, what we want to find is sine of 84. Now we have 48 degrees and 42 degrees in our triangle, okay? But now the problem is how are we going to get 84? There is no 84 here, but if you double 42, then you'll get 84. So now this is a case where we have to use double angles in our triangle. So we got sine 2 times 42, and sine of 2 is 84. So what is sine of double angle? 2 sine 42 cos 42. Now let's take this triangle here and substitute everything that we need. Right? So let's substitute everything. So we got a 2 in the front, right? What is sine of 42? Sine is t over 1. So that's just t. And cos 42 is adjacent of our hypotenuse. So that is just square root 1 minus t squared. Putting everything together is just 2t into square root of 1 minus t squared. Right? 2t. 2t times the square root of 1 minus t squared. Yep. So that was, so obviously if you can't find angles within the triangle, you got to manipulate them in terms of double angles. Yes. So I'm going to leave out this part here. C, that's D, and that's E. Look at the next one. Next one say, what is cos of 3? How can I find cos 3 from this triangle here? So I manipulated the previous problem in terms of my double angle, right? That's fine. But now, how am I going to find this now? How am I going to find cos 3? 3 is so difficult here. Okay, so cos of 3 I can't find, so I need to use maybe special angles and one of the angles from here. So that works. Cos of 45 minus 42. 45 minus 42. Yes, that works. 45 degrees is a special angle, 42 is the angles of the triangle. So what I use here, it was special angles. Right, now we can solve the problem. That is cos 45, cos 42 plus sine 45, sine 42. Right, so great. Cos 45 is 1 over root 2. Cos 42 is adjacent of our hypotenuse. Sine 45 is also 1 over root 2. And sine 42 is opposite of hypotenuse, t. Right, so I can multiply this by root 2 over root 2. So multiply each term by root 2 over root 2, okay? So you got root 2 over 2 square root 1 minus t squared plus root 2 over 2 times t. Now you can see the denominator is just 2. And the top is root 2. What is root 2 times square root 1 minus t squared? You got root 2 and root 2, so you can multiply that inside. So it can become 1 square root. 2 minus 2t squared, right? And this is root 2t plus root 2t. Okay, and that's my final answer. All right, so great. We have one more question here. So we can do a similar thing like this for sine 12, right? What can we do for sine 12? 12 will be, how can you get 12? 30 plus, no, 42 minus 30. 42 minus 30 is 12, right? 42 degrees is the angles of triangle, 30 degrees is the special angle. So we are using special angles and angles of triangles, right? Special angles. So the sine 42 cos 30 minus cos 42 sine 30, okay? Equals sine of 42. Sine of 42 is 42 degrees was down, t over 1. Cos of 30 is root 3 over 2, subtract. Cos 42 was 1 minus t squared, and sine of 30 is half. And this is easy now. Root 3t over 2 minus square root 1 minus t squared all over 2. Just want to give you one more, which is creating one more question. EF. I deleted that. I didn't realize. Oh, should have changed it to something else. All right, one more question. EF. Using this, I want to find what is cos cos of 6 degrees. Now, how am I going to get cos 6? Cos 6, I can add and subtract from here. So I can say 48 minus 42. Cos of 48 minus 42. So now you're going to have, so cos of 48 minus 42, cos 48, cos 42 plus sine 48, sine 42. Let's simplify. Right, easy. Using this diagram. What is cos of 48? Adjacent of the hypotenuse. I'm going to put over 1. So just square root 1 minus t squared. Cos 42 is just t plus what's sine of 48? 48 is opposite of hypotenuse, square root 1 minus t squared. And sine 42 is t. Okay, so you see you got t times this plus t. So just 2t square root of 1 minus t squared. Okay, so we got the same thing, 2t into 1 minus t squared. And you know cos of 6 is the same thing as saying, cos of 6 is the same thing as saying, sine of 84, because 84 plus 6 is 90. So if you go to sine of 84, you will find that the answer was cos of sine 84 was also this. But over here, I used a double angle because 2 times 42 gave me 84. But over here, cos of 6, I use compound angles, right? So now in triangles, you got to use these things, triangle problems, right? So I'm just going to summarize here. For triangles, you got to use compound angles. compound angles, you got to use double angles, right? And if none of them works, you move on to special angles, right? And this is like higher order thinking with the special angles, right? And thank you very much.